Assalamu alaikum. Hi everyone, my name is MUSHARY AL-FARWAN. Today I will talk about the hydroelectric power or hydroelectric energy. This kind of energy is very important in our future because it has many benefits. Uh, it has many benefits more than another kind of energy. My content or my outline, I will talk about what is the hydroelectricity, also the history of hydroelectricity, method of the generate hydroelectricity, and I will give you some advantages of the hydroelectricity. In the end, we will talk about the word hydroelectric capacity. What is hydroelectricity? Hydroelectricity is the term referring of electricity generated by hydropower, the production of electrical power through the use of the gravitational force of falling or flowing water from this way until from up to down in this way. The hydroelectricity is the most widely used form of the hydroelectricity is the most widely used form of the renewable energy. Once a hydroelectric complex is constructed, the project produces no direct waste and has extremely lower output level of the carbon dioxide CO2 than fossil fuel powered energy plants. Now we will talk about the methods to generate hydroelectricity. There are 4 methods to generate hydroelectricity. First method, it's called tide method. Second one, pumped storage method. Third one, run of the river method. The last one, conventional method. I will explain each of them in next slide. Third method, a tidal power plant makes use of the daily rise and fall of water due to tides. Can also be batched to generate power during high demand periods. Less common types of hydro schemes use water's kinetic energy or undamaged source such as undershot water wells. Pumped storage method and run of the river method. These methods produces electricity to supply high peak demand by moving water between reservoirs or between tank, which is here in this picture, this one and this, at different elevations at times of low electrical demand. Pumped storage schemes currently provide the most commercially important means of large-scale grid energy storage and improve the daily capacity factor of generation system. Conventional method. Most hydroelectric power comes from the potential energy from dam, driving water turbine and generator. The power extracted from the water depends on the volume and on the difference in the height between the source and the water's outflow. To do that, you should use a large pipe, which is called a bin stock. As we can see here in this picture, this is the picture for large pipe, which is called a bin stock. Here is advantages of hydroelectricity. First advantage, the major advantage of hydroelectricity is elimination of the cost of fuel. Second one, since hydroelectric dams don't burn fossil fuels, they don't directly produce carbon dioxide. The third advantage is a hydroelectric plant may be added with relatively low construction cost. Now we will talk about the world hydroelectric capacity. World renewable energy share us at 2008 with hydroelectricity more than 50% of all renewable energy sources. World renewable energy potential. The ranking of hydroelectric capacity is either by actual annual energy production or by installed capacity power rating. A hydroelectric plant rarely operates at its full power rating over a full year. The ratio between annual average power and an installed capacity rating is the capacity factor. Here is 10 of the largest hydroelectric producers at 2009. We choose 10 countries, which is China, Canada, Brazil, United States, Russia, Norway, India, Venezuela, Japan, and Sweden. This side will give us the value of annual hydroelectric production, and this side will give us the value of installed capacity. Also, this side will give us the value of capacity factor, and the last one, it gives us the value of percentage of total capacity. Here is a short video about hydroelectricity. We can let's start to see this video.
$170,000 cubic meters of water flow past here every minute at almost 60 kilometers per hour. That's enough water to fill about 100,000 Olympic swimming pools every day. Standing here, you can actually feel the power of the water. Harnessing that power is what hydroelectric stations have been designed to do for over 100 years in Ontario. In essence, they are factories that convert the energy of falling water into the flow of electrons, or what is commonly called electricity, the electricity that powers the province. Most hydroelectric stations use either water diverted around the natural drop of the river such as a waterfall or rapids, or a dam is built across a river to raise the water level and provide a drop meter to create a driving force. Water at the higher level is collected in the forepeak. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within coils of copper wire called the stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent across transmission lines. The falling water, having served its purpose, exits the generating station to the tailrace, where it rejoins the main stream of the river to continue the cycle of creating clean, renewable energy for Ontario.
In the end, I'm sorry, but in the end, this energy is very important to us in our future. It's really useful energy, and also it is not expensive, and we must use this kind of energy in our future, and work to development this energy in our field life. Thank you so much for listening to my presentation, also to listen to me, and I hope you get some benefit or some new information about this topic, which is hydroelectricity energy. Thank you so much. Assalamu alaikum.